Assalamualaikum and hi everyone. I am Nurul Izzah binti Shahabuddin with metric number 256853. As to fulfill the requirement for the course SQQP 4073, Research in Quantitative Sciences 2, I would like to present my report's presentation with a title of Analysis of Restaurants Queuing System using Discrete Event Simulation DES. This video will be divided into 6 parts, consists of introduction, literature review, methodology, result and analysis, discussion, and also conclusion. First, introduction. What is simulation? It is an approximate imitation of an operation system that represents its operation over its time, and has been widely used by various sectors to acquire the behavior of the system in order to aid the problem-solving process. A self-serving restaurant, which sells a variety of Malay cuisine dishes, has been selected by the researcher. However, there is a formation of queues and long waiting time, especially at the payment counter during peak hour, which will actually cause the customer to face unnecessary delays. In this study, 3 research objectives in order to answer the 3 research questions have been proposed, which are to develop a simulation model of a queuing system in order to analyze the current performance of the restaurant. Second, to identify factors that affect the length of queue in the restaurant. And lastly, is to propose solutions for a better service provision in improving customers' flow and customer satisfaction of the restaurant. This research has been focuses on queuing operation at Nasi Lemak Cita Sayang restaurant. Next is the literature review. What is defined by queuing system? According to Akil in his research in 2016, it is a mathematical model used to describe the congestion process managing the flow of customers and streamlining the experience of queuing. Then, a research made by Velumani, Picha and Tang has mentioned that the shortage of working staff in a restaurant will also cause bottleneck to occur. This also can be supported with Ramasamy, Hao and Chua when they mentioned that the restaurant's layout also plays a vital role in extending the length of queue in the premise. Some of the solutions proposed by the past researchers to solve this problem in their study is by developing extra workforce to bring down the crowd. According to Ahmad and others, in their research in 2018, brisk action from working staff will help in reducing and eliminating the queue during peak hour in the restaurant. As for the approaches used to minimize customers' waiting time is by using discrete event simulation. Mola said that it is referred to as a systems modeling in which the state's variable changes at a discrete set of points in time, while Gilmers and others use chi-square goodness of fit as to determine the frequency and theoretical frequency for the rate of service calculation. Now is the methodology part. Research design phases will help to reflect the idea, formation and plan of investigation as to procure the solutions to the research questions or problem of the study. In this study, there are 6 phases being identified, which are the identification of research problem, review of literature, data collection, proposed model and analyzed data, result and discussion, and the preparation of report. The initial model will be developed using Arena simulation software, and there is 150 data being collected via observation. In this study, 2 interventions will be proposed to reduce the issue by the researcher. Discrete Event Simulation (DES) is an efficient and convenient modeling software tools that allows the user to build a simulation model and perform changes and modifications on it. As to complete this study, there are 6 phases required for the development of the model. Observation was done at the Nasi Lemak Cita Sayang restaurant to identify the actual scenario of the restaurant in order to enable the modeling of the restaurant system to be made as precise as possible. The observation conducted will also aim to determine the actual layout of the respective restaurant. A few assumptions, such as customers enter the system individually, not in group, customers are served on a first-come, first-served basis, and a counter can only serve one customer at a time, will be applied in the study. while validation is a process of reaching an acceptable level of confidence that the inferences drawn are correct and applicable to the real-world system being presented. Input Analyzer is a standard tool that has been widely used in Arena software as it is specifically designed for the purpose of to fit the distributions of data. By fitting all the applicable distribution to the data, it will help in the calculation of statistical tests and would display the best distribution with a minimum value of square error. In this initial model, there are three counters consisting of food, beverages, and payment counters in the system. One arrival module has been used where the entity is the restaurant's customer. There are four processes modules consisting of food, beverages, payment, and dine-in counters which will actually work as resources. Then there are two decide modules that function to let the customers decide whether to order beverages and whether to take away or to dine in the premise. Lastly, leave after payment and leave after dine-in modules will work as disposed entity in this respective system. Customers' waiting time is considered to be high and should be reduced as it could adversely affect the level of customer satisfaction. In addition, the average rate for utilization at this counter is high, indicating that this restaurant is fully occupied all the time and is really busy during the peak period. Thus, two interventions has been proposed, which is to modify the restaurant's layout. This is because in the current layout of this restaurant is implementing the segregation of duties where one employee has to perform two tasks, which is to become a cashier and have to pack all the food for the takeaway customers. Next is to deploy extra staff as this restaurant is actually having a shortage of workers as there is only one worker at every counter in the restaurant. This is the summary of the comparisons result obtained from all the three models. According to the table, the total production numbers in the base model with a value of 127 customers are much lesser in the base model compared to the interventions model. In contrast, both interventions 1 and 2 has a better total number of productions which are 139 and 144 customers respectively, indicating in these models the number of customers completed the process is higher. For the current queuing system, the average waiting time of customers in the system is 17 minutes and 55 seconds. Comparing this value with the values in both the proposed models, there is a decrease of time in these models, indicating that there is a significant improvement in terms of average waiting time during the simulation period. The utilization rate for the payment counter was reduced from 90.464% to 62.513% and 43.208% in both the interventions respectively. This reduction in the percent values indicates that the level of busyness in the both counters are much lessened compared to the current model. In conclusion, all the objectives of this research were successfully achieved. The interventions proposed are proven to reduce the average waiting time of customers in this restaurant. By comparing both interventions, the intervention 2 produced better result than intervention 1 in terms of the average waiting time in queue and the utilization rate. This conclusion aligns with the finding on previous work, which is instead of being delayed due to the long queues, the customer's waiting time is reduced after the number of working staff in the restaurants are increased.